Hello, algebra students. Mr. Irvis here from Crickwater Studios, bringing you today's presentation, which is Unit 3B. Um, you should have the one that says review at the top. So this is the YouTube version. I hope you guys watch this before you try the classwork or homework, whatever we want to call it nowadays. So I'm going to get right to it here. For the function f of x shown in the graph below, over which interval is f of x greater than 0? Well, being greater than 0 means that's above the x-axis. So one easy way to do this or visualize this is to kind of cover up everything that's below the x-axis, and we can see that this graph is above the x-axis at negative 1, 2, 3, 4, 5, 6, 7, 8. That's negative 8. And it is dips below right here at x value negative 1. So I'm just going to go with from negative 8 to negative 1. Okay, and that is choice number 4. And we are done there. All right. Question number 2. And I did a little drawing here. I made a function machine. Domain are the x values of a function, and they give us negative 16, 8, and 38. So those are the x values of a function that would go in, and they tell us the function is x subtract 2, then divide by 6. Which of the following is the values is a member of the range? Well, the range are the y values. So if these are the x's or inputs, and these are the ranges, these are the outputs, well, we're just saying what happens if negative 16 goes into the function. Well, the machine is going to go negative 16, take away 2, makes negative 18, divide by 6. It's going to kick out negative 3. And you do the same thing for 8. Put 8 in, 8 take away 2 is 6. 6 divided by this 6 kicks out 1. And then there's one more. Let's input 38. Okay, 38 goes in, subtract 2, we're at 36. Divided by 6. Output is 6. So there's only one I see here, and that's right there. 6 just kicked out when we put 38 in. So I'm going with choice 4. All right, number 3. All right, for the function shown below, which of the following represents the domain of the function? Now remember, the domain we just talked about, those are the x values. So in this case, I prefer to roll my pencil left to right and figure out when is the lowest x value, or the first x value of the graph occurs. And it looks like right here at negative 2. And the graph continues to 1, 2, 3 on the x-axis. But notice that's an open circle, and this one's a closed circle, and that means something. So I'm going to go right here to choice number 3. You'll notice the square, the bracket, which means that negative 2 is included. That's the filled in circle. And it continues to 3. Open circle, that's why we're using or seeing the round there. So this is choice number 3. And that's all there is to that. All right. Number 4 is about a piecewise function, which tells you that sometimes you're going to use this piece to calculate, and sometimes you're going to use this piece to calculate. Well, specifically when? Well, use this piece up here if any x value you think of is smaller than or equal to 3. Use this one if it's bigger than 3. Well, we're interested in negative 1. Well, is negative 1 bigger than 3? Smaller than 3? Equal to 3? Well, if you think about it, negative 1 is definitely smaller than 3. So, smaller than 3 says we should use this. Therefore, h of negative 1, I'm going to use 5 minus negative 1. And watch out for the minus negative becomes plus positive, and you end up getting 6 as your output. And that's all there is to that one. So that one wasn't too bad. This one here, this last one, number 5, I will say is a legit tough question. Definitely, I'm hoping you're watching this before you try the one at home, which is also number 5. So here's our function. G of x defined as twice f of x, add 6. But f of x is its own function. Therefore, if you want to figure out g of 9, g of 9 means you're supposed to be plugging 9 in where you see an x. Well, in the g function, it looks like this if you put 9 where x is. So double f of 9. Well, you can't figure out what f of 9 is until you actually get the f function out. And the f of 9 would have to be calculated using this function. So you need to do 4 minus 2 times the square root of 9. If you can calculate that, you'll be dealing with 4 minus 2 times 3, which is negative 2. That's a 6. 4 take away 6 is negative 2. So all I know is what f of 9 is. So now I go back and I try to figure out g of 9. I'm running out of space here. G of 9 is when you multiply 2, when you place that negative 2 in, and then add 6. And so you're going to end up with negative 4 here, plus this 6, kicking an output of 2. And that's multiple choice, number 2. So that's a pretty tough question, but we did cover that during our unit. So let's turn this over to the back page and look at number 6. And you can see I put some notes here. It says state the range. Now the range is just what's the lowest y value to what's the highest y value. So if you kind of want to just roll your pencil like this, you can see that the first y value that it hits right here happens to be negative 4 on the y-axis. And the highest y value, and you just keep rolling your pencil, and the highest y value that we have available is right up there. And that, I believe, is all the way up to 12. Now, I don't notice any open circles or anything, so that means negative 4 is included and positive 12 is included. So you got a couple options. Option 1, negative 4 to 12, both included. Some kids are going to want to use negative 4, and make sure you use y though, to 12. Both of these get the same job done, okay? And I think we have to know both of them. All right, so then we get to number 7, which is discussing functions. And I already wrote down here an input x can have at most one output. Now, let's just imagine that this input right here is 1. I don't know that it is, but imagine it is. If 1's an input, it'll have an output here. It'll be that high, but it'll also be this low. That's not possible. You can't have 2 outputs for the same input. So some of you guys learned the vertical line test. So if you draw a vertical line and you hit it twice, that's a failing of the vertical line test. So this over here fails VLT, vertical line test. That's enough evidence to say not a function. This one over here, I can't find any spot where an x value kicks out more than one y value. They all kind of match. And if you're doing the vertical line test, anywhere you draw a vertical line, you're only going to get one touch. So that means that this passes the vertical line test. Therefore, this is a function. And that's pretty much it right there for graphs. Now this last question is about a piecewise function, and you're going to do a little bit of graphing. All right. So they say as piecewise function to use this graph sometimes. Well, when do I use that graph? Well, if any of the inputs are from -6 to +2.
Here's what I found.
Ooh, my watch. Sorry, guys. So from -6 to 2, I'm going to put all my inputs: -6, -5, -4, -3, -2, -1, 0, 1, and 2. Those are all the numbers from -6 to 2 as they say to use. Also, maybe you would graph this if any of the x values are from 2 to 5. Now notice, 2 is really not included. There's no equal line there. So I want to put it in here. 2, 3, 4, and 5. Okay, but I'm just going to circle that 2 as a reminder. That's really not a part of the graph. And if you graph it, probably going to have to use an open circle on there. So keep that in mind. All right. So -6 put into here, calculate, is -1. All right, now I'm going to speed this up. I can, because there's a whole bunch of fractions, and this is going to bother you guys a little bit. Don't let it bother you. Zero is a half, 1 is 3/4, and let me slide this up. A 2 kicks out a 1. Now the reason I tell you don't let it bother is because you know that if it's a decimal or a fraction and we don't need to graph it, don't graph it. I only care about the nice ones. I only need a couple of dots to make a line, so I've got 3, that's enough. Over here, I'm putting these numbers but into here. 2 times 2, take away 5, kicks out -1. Put in 3, kicks out 1, 3, and 5. Okay, so those are all graphable. All right, so let's get this, and we're going to go to -6, -1, make our first dot. That's from here. -2, 0, left 2, 0, and 2, 1. That's 2 and 1. And I got a ruler right here. I don't know what I'm doing. All right, so okay, I'll make sure I use a ruler, because if you guys didn't use a ruler, I'd probably say something. All right, -2, -1. Now remember, we said this is going to be an open circle, so excuse me, 2, -1, over to 1, 2, down to -1. We say open circle, so just leave it open. 3, 1, over to 3, up 1, and 4, 3, over to 4, and up 3, and 5, 5, over 5, up 5. Okay, so same thing. So starting from the open circle, and we have our piecewise linear function. It happens to be disjoint here, which is allowed, happens, and that's all there is to it. Now, when you guys do your homework, classwork, you guys have something very, very similar. Okay, if you don't have the option to print this, that's okay. Get a straight edge, draw an y-axis, do your very best, and still go ahead and graph and do everything that I showed you on this video. All right, have a nice day, everybody.